All right, so ladies and gentlemen, we are looking at hyperbolas. We've talked about circles, we've talked about ellipses, now we're talking about hyperbolas. Most of you know like what a circle is, and a lot of you have seen like an ellipse looks like an oval, okay? So now I'm looking right here at a hyperbola, which a lot of you don't know. So if you look, all of the conics that we've talked about so far, circles, ellipses, and now hyperbolas, have to do with cones, and it's how you slice the cone. So if we look right here, if we have two cones on top of each other, I think that kind of looks like an hourglass. You guys know what an hourglass is? Where it like drops the sand from the top to the bottom? Okay, so I think this kind of looks like an hourglass, and it's if we're taking a slice out of the side of it. Okay? So a hyperbola is a set of points such that the difference of the distance from any point on the hyperbola to a fixed point remains constant. These fixed points are called foci, or focus points. Okay? So D1 minus D2 remains constant for all points on the hyperbola. So see how it kind of makes a triangle? If I take D1 and subtract D2 from it, it's the same. Okay?
I got a question.
Yes?
What does D mean? Diameter?
D is like the distance, the length. I'm in the middle of recording right now, so if we could be quiet, that would be great. Okay, this is my horizontal, opens from left to right. If we can see right here, I'll like put it in color. This right here is what I'm looking at for right here. That's the hyperbola. That's my graph. But then there's all these other points here. Okay? These points right here, those are my vertices. These points up here are my co-vertices. Okay? And this is my focus point on one side. This is my focus point right here on the other side. All right? And if we change it vertically, again, these are my hyperbolas. Okay? What are these 2 points right here? If you're looking at the other one and comparing, what are these 2 points right here? Vertices, good. These are vertices. What are these 2 points right here?
Co-vertices.
Co-vertices, good. Okay, those are my co-vertices. And what are these points right here above and below my hyperbolas? Focus points, yeah. Okay? So the center is HK, which is the blank of the focus points. It's the midpoint. So if I know my 2 focus points, I just add them together, divide by 2, that gives me my center. The asymptotes are diagonal lines. They are like guides. See how this is drawn through the vertices, but along those asymptotes? And remember, asymptotes is just a place where it can't cross. The vertices or turning points are positive or negative A, units away from the center, and the co-vertices are positive or negative B, units away from the center, where the focus points are positive or negative C from the center. The formula to find C is A squared plus B squared equals C squared. Yep, just like the Pythagorean theorem. Can you guys see this? Do I need to move in a little bit?
Thing we did, it wasn't.
Right, when we talked about ellipses is A squared, excuse me, A squared minus B squared, where this is plus. So we know that it's the difference between them. Okay. So we have, again, 2 standard forms, depending on if it's horizontal or vertical. Okay? We've got x minus h squared over a squared minus y minus k squared over b squared equals 1. And then we're looking at vertical. It's y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay? So the important part here We know this is not an ellipse because it has a subtraction sign in the middle instead of an addition sign. Okay, asymptotes. Those are the equations of those dotted lines that we see there, okay? The equations for them are y equals plus or minus b over a, x minus h plus k. Okay, this should look a lot like standard form for a vertex form, except there's nothing squared about it. Or y equals positive or negative a over b, x minus h plus k. Now look at these steps that it's written below here. These are really important. Writing the equation in standard form first so that you're able to graph. 2, we're going to graph the center. Then we're going to graph the vertices using the first denominator and finding a. Graph the co-vertices. Use that first denominator for b. Use the formula c squared equals a squared plus b squared to find the focus points or foci. And write the equations for the asymptote and then graph them. Okay, and then we can graph our hyperbola. Okay, we're going to try one. These are a lot of steps, but this right here, it's written right here, guys, so that you can use those steps in order to do them. To do your homework, you got to think about these steps when you're taking this next quiz. Okay. We're going to look at number 1, how to graph this. Okay, the first thing we're going to do is this in standard form? We've got x squared over 4 minus y squared over 9 equals 1. Standard form, yes or no? Yes. Okay, so the first thing we're going to talk about is the center. Is there anything being added or subtracted to x or y? So what's the center? 0, 0, perfect. Okay, now, unlike the ellipse, whichever is the bigger one is a, this one, the one that comes first is always a. So a squared equals 4. So a is equal to, what's the square root of 4, guys? 2. And b squared equals 9. So b is equal to 3. Okay, so let's talk about the vertices. This is under the x, so I know it's going to change the x. So 2 away from 0 is 2. And then we have to go the opposite way. Negative 2 away from 0 is negative 2. So those are my vertices. Your co-vertices are 3 away from 0. So we're going to go 0, comma 3, and 0, comma what? Negative 3. Good. Okay. Yeah. All right. So let's look at trying to find my foci points. We're going to go c squared equals a squared plus b squared. So c squared equals 13. Then we're going to take the square root of each side, and I get c equals the square root of 13, which is approximately 3.61. Okay, so it's 3.61 away. So that means it's 3.61, comma 0, and negative 3.61, comma 0. Why did I put it where the x, these are x, comma y. Why did this one go where the x is? Because foci points always go with the vertices. Okay, so if my vertices are x, so my foci has to be in the x position. Okay? All right, asymptotes. Now, let's look, if you want to look back at what the equation for an asymptote is. For this one, this is a horizontal. So I know my equation for asymptote is y equals plus or minus b over a times x minus h plus k. Yep. Okay. So I know that b is 3 and a is 2. So first of all, I'm going to write y equals 3 over 2. And when I have one that's positive, I have one that's negative because I have 2 different equations. Okay? I've got x minus 0 plus 0. x minus 0 plus 0. So because of these zeros, I end up with y equals 3 halves x and y equals negative 3 halves x. All right, I like to start, yep. I like to start with graphing my asymptotes first. Okay, this is just like graphing any straight line. There's nothing being added or subtracted to it, so I know my y-intercept is at 0. And then I'm going to go up 3 over 2, up 3 over 2, up 3 over 2, or down 3 over 2, down 3 over 2, down 3 over 2. Right there. That's my first asymptote. And then I'm going to do my second one where I start at 0, and this time I go down 3 over 2, down 3 over 2, down 3 over 2, or up 3 over 2, over negative 2. Shh. Up 1, 2, 3 over 2. Hold on. Up 3, 1, 2, 3 over 2. So I've got these things as my asymptote. The next thing I'm going to do is I'm going to plot each of these: center, vertices, co-vertices, and focus points. My center is 0, 0. My vertices are 2, 0, and negative 2, 0. My co-vertices are 0, 1, 2, 3, and 0, 1, 2, 3. Okay? And then we're just going to make a box around this. This helps us kind of know where we're doing these. And then my focus points are 3.61, so it's like right in here and right up here. So now I can graph my actual hyperbolas, which will go right here along each of these, through your vertices and along your asymptotes. Questions about this? Okay. Let's start with number 2 then. Let's look at number 2. Okay. Can somebody tell me what the center is for number 2? Is anything being added to the y or the x's?
No.
So the center is?
0, 0.
Good. Okay. Vertices are a little bit harder. Remember, vertices always come first. So if this is 36, a squared, please don't talk anymore unless you're answering my question. A squared equals 36, so what does a equal? Okay. Is there anything under x squared?
No.
So we know it has to be 1. B squared equals 1, so B has to equal 1. Okay? So I know my vertices. So this is under which letter, x or y? It's under y. So I know my vertices are 0, 6 and 0, negative 6. Okay? The y value changed. Okay? My co-vertices are 1, 0 and negative 1, 0. Okay, to find my focus points or my foci, I'm going to do c squared equals a squared plus b squared. That gives me this 37. I'm going to take the square root of both sides. So c is approximately 36 plus 1 is 37. The square root of 37 is 6.08. Now careful, this changes, the vertices and the focus points go together, so I have to change my y value. So then this is 0.6.08 and 0, negative 6.08.
So the y value gets changed to a foci?
If the y squared is listed first. See, for the other one, x squared is listed first, so it changes the x. Shh. Ladies, gentlemen.
So vertices, you change the x, covert, you change the y?
No, it depends.
It just
So-
depends on what it is.
Right, so if x is listed first, see how x is listed first? Then it's my x values for vertices. Y is listed first here, so it's my y value for vertices. And vertices and foci go the same. Okay. Asymptote. I know that this is my asymptote, but my equation is slightly different here because this is a vertical. So this is y equals plus or minus a over b, x minus h plus k. Okay? So I know my h and k are 0, so I don't need to worry about those. So my a value is 6. So I'm going to say y equals 6 over 1 x, or y equals negative 6 over 1 x. Okay, so the first thing I'm going to do is I'm going to graph my asymptotes. I'm going to start at 0 and I'm going to go up 1, 2, 3, 4, 5, 6 over 1. Or at 0, I'm going to go down 1, 2, 3, 4, 5, 6 over 1. So right here in blue, that's my asymptote. Then I'm going to graph the opposite way, where I'm going to go down 6, 1, 2, 3, 4, 5, 6 over 1, or up 6 over negative 1. Okay? Now, I'm going to graph my center as 0, 0. My vertices are going to be 6, 0 and negative 6, 0. My co-vertices are going to be 1, 0 and negative 1, 0. And then you can barely see my focus points here. They're just past these. Okay? This makes a nice little square right here, which kind of helps you, or rectangle, which helps us figure out where to put our stuff. Hyperbola goes like this and like this. Okay, let's do another one. Questions about this so far? Okay. Let's look at number 3. And the first thing I want you to think about when you see number 3 is it going to be vertical or horizontal? Shh. Which comes first, the x or the y? X comes first, so this is going to be a horizontal. Yeah, let me just go through that.
How do you do that part?
Well, you have the asymptote going like this. And then you just make sure it goes through there. Okay. So, we know it's going to be horizontal, which means like the hyperbolas are going to go like this way. Okay? So, now we're going to say a squared equals 25. So, a equals 5. And b squared equals 16. So, b equals 4. Okay? Now, what is x and y being added or subtracted? So we've got x minus 3 and y minus 2, so it's the opposite of those, so my center is 3, 2. Everybody sees where I get my center from, right? Okay, so we've been doing that for a circle, for ellipse, for everything. That's the same. Okay, now my vertices are whichever comes first. In this case, it's x. So I know my y's aren't going to change. Okay, that's why I'm going to put a 2 for both of those. Everybody okay with that so far? See how the x comes first? That means my vertices are along 2, okay, because the y's don't change. But now for the x value, I'm going to have to add and subtract 5 to 3. 5 plus 3 is 8, and 5 minus 3 is negative 2. I mean, excuse me, 3 minus 5 is negative 2. Okay. Co-vertices, what's going to stay the same as the center for the co-vertices? 3 for the x is going to stay the same. Okay. We're going to go 4 plus 2 is 6, and negative 4 plus 2 is negative 2. So far, so good? Okay. Remember the focus points, we have to go c squared equals a squared plus b squared. So we go c squared equals 25 plus 16.
41.
So c squared equals 41. Square root both sides, and c is approximately 6.40. Okay? Remember that 6.40 is going to be added to what? Vertices and co-vertices go together. What changed for the vertices? The x value, so the focus points have to change for the x value. 6.4 plus 3 is 9.4, comma 2. Negative 6.4 plus 3 is negative 3.4, comma 2. Okay? So let's talk about these asymptotes. Remember, I'm using that equation again, that y equals b over a. I have to do plus and minus, x minus h plus k. So we're just going to fill that out, first of all. So we're going to go, and I will give you this equation on the quiz. So we're going to say y equals plus or minus, the b value is 4, over the a value, which is 5, parentheses x minus the h value is 3, plus the k value is 2. Then we're just going to distribute this and solve. So we get y equals 4/5 x minus 2/5. Because I just distributed this and then added 2. And I get y equals negative 4/5 x minus 2/5. Okay. So the first thing we're going to do is we are going to plot our asymptotes. So I'm going to start at negative 2/5. So that's right about here. And then I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Or down 1, 2, 3, 4 over 1, 2, 3, 4, 5. This is hard because I'm using what I know about how to graph lines as well as all this other new stuff that we're talking about. So we start again at negative 2/5, and this time I'm going to go down 4, 1, 2, 3, 4, to the right 5, 1, 2, 3, 4, 5. And I'm going to go up 1, 2, 3, 4, to the left, 1, 2, 3, 4, 5. So those are my crazy looking asymptotes. Now my center is 3, 1, 2, 3, comma 2. So that's my center. My vertices are 8, 2, so 3, 4, 5, 6, 7, 8, and negative 2, 2. And then my co-vertices are 3 and up 6, 2, 3, 4, 5, 6. And 3 down 2, negative 2. Okay? And then my focus points are like 9.42, so it's like over here. And this is negative 3.42. So I'm looking at this box right here to kind of help me where my points are going. Okay? So I go from the vertices and I just put it along the asymptotes. Gonna go along the asymptotes. Okay. All right. Let's try number 4 because I still have a lot of people that are confused. Okay. Can somebody tell me what the center is of this? 3, negative 1. Okay, so you guys at least know that part, right? You can find the center. Which one is A? A always in a hyperbola comes first. So A squared equals what number? 36. So what does A equal? 6. Good. B squared equals 9. So what does B equal? 3. Okay. Should we just do the C squared while we're at it?
Yeah.
Okay. C squared equals A squared minus B squared. So C squared equals, plus, sorry, not minus, plus B squared. So C squared equals 45. So C is approximately 6.71. So we're going to use all this information to find our stuff. Now, remember, A talks about vertices, but 36 is under what letter, X or Y?
Why?
Y. So that means I am going to change my Y. So I'm going to leave X alone. Now, remember, this is 6 plus, why did I have, this is the wrong way, sorry. Negative 1 comma 3, not 3 comma 1, because X is with the 1 and Y is with the 3. Sorry. Okay, so 6 plus 3 gives us 9, and negative 6 plus 3 gives me negative 3. Let's do the covertices. The covertices is under the X value, so the X doesn't change. So I'm going to leave my Y alone. What's 3 plus negative 1? That's 2. What's negative 3 minus negative 1? That's negative 4. Remember, vertices and focus points go the same, so that means we are going to change our Y value. 6.71 plus 3 is 9.71. Negative 6.71 plus 3 is negative 3.71. Okay, now we're going to do the asymptote. We are going to say Y plus or minus, and we're going to say, because this is a vertical one, we are going to say A, which is 6, over B, which is 3, times X plus 1 plus 3. Okay, so 6 divided by 3 gives us 2, right? 2 times X is 2X. 2 times 1 is 2. Plus 3 means that's 5. So we're going to get Y equals 2X plus 5. And if it was negative, we would get Y equals negative 2X plus 1. We're going to graph both of those. We're going to start at 1, 2, 3, 4, 5. And we're going to go up 2 over 1, up 2 over 1, or down negative 2 down over left 1, down negative 2 left 1. Okay, and we have this nice asymptote line right here. Okay, now we're going to go the other way. We're going to start at 1, and we're going to go down 2 to the right 1, down 2 to the right 1, all the way across the paper. Or up to negative 1, up to negative 1, up to negative 1. This is basic little Algebra 1 stuff. I know it looks crazy, but it is. All right, now we're going to plot all these points. First, we're going to go negative 1, up 1, 2, 3. Oh, look, it's right there in the center. Now we're going to go negative 1, 9, so that's 3, 4, 5, 6, 7, 8, 9. And negative 1, negative 3, 1, 2, 3. Okay, we're going to go for our covertices. We're going to go to the right 2, up 3, to the left 1, 2, 3, 4, up 2, right there. And then my focus points are going to be negative 1, 9.7 up here, and negative 1, negative 3.71. Shh. We get this weird rectangular box that helps us to see that we have this as our hyperbola right there. Okay, we are going to stop there. You do have homework that you need to work on. Okay. How about this, guys? I want you to attempt the second page But it's a little bit harder because you have to do some complete the square stuff. But please attempt the second page.